Hey everybody, this is Larry. I'm in New York, day 2 of the March Leetcode Daily Challenge. Hit the like button, hit subscribe button, join me on Discord. Just walking around testing the camera. Alright friends, I'll see you later. Hey everybody, this is Larry. This is day 2 of the March Leetcode Daily Challenge. Hit the like button, hit the subscribe button. Join me on Discord. Let me know what you think about today's problem and this contest and everything. Wait, what am I talking about? Just this problem. I did the contest yesterday. I don't know. I took a nap and I just woke up. That's my excuse. I'm sticking to it. Hope you like the intro. I just got my camera back because there was something wonky about it, so I'm just testing it. Let me know if there's something wrong with the quality. I mean, the video quality. Maybe me just saying random stuff is not that useful, but that's another point. All right, let's take a look at today's problem. We have 1536 minimum swaps to arrange a binary grid. Oh yeah, also I ran another 5K this morning, a much slower time, like deliberately, and just kind of beat up, still, because I wasn't going too slow, I wasn't zone 2 or something like that. But it was good. Feels good. I'm feeling I'm running back into shape a little bit though. Who knows? I'm not really optimizing for it this year, which is for better or for worse. Yeah. What was I going to say? Oh yeah, hope you enjoyed the footage of New York. But let's take a look at today's problem. 1536 minimum swaps to arrange a binary grid. You have a squared grid. You want adjacent grids. Okay. You can choose 2 adjacent rows and then swap them. What does that mean? What do the red and green mean? Anyway, a grid is said to be routed if all of them are return min number of steps. Okay, but so that's like I mean, whenever you hear something about, well, maybe not, but I don't know what this red and green means. Do they tell you? Oh, it's just that one is in violation. Is that why? Is that what they're saying? I see. Okay, but I don't know why they have to guess that. They should just tell you. But all right. I mean, my first instinct, honestly, is going to be because you can choose 2 adjacent rows and then swap them. That's a very bubble sort-y idea in general, right? But this particular problem, well, n is 200, but this particular problem, it's not, you don't need to order them though. I mean, ordering would be a valid solution, but it's not a minimum number of step solution. So yeah, so that's one. Why am I like getting, I don't know. Oh, man, I don't know. I think, okay, I see, maybe. I think in terms of requirement, which each row is representable by the last one, right? So that's the first thing that I would notice, is because that the first one, or the last one, maybe you want to call it that way, like the first one from the right side will determine what like almost like a constraint of what row you can end up in, right? So that's the first step, and because of that, then it allows you to do swaps much quicker and comparisons much quicker, right? So that's maybe my first pass, and then now you have n numbers, and then n numbers you could do all kinds of crazy things because n is only 200 anyway, instead of n times n numbers is what I mean, right? Okay. How would I do it? Just trying to think. I mean, I guess it is still gonna be bubble sort-y. I'm trying to think about like with these kind of problems, there is some sort of a greedy component, and with greedy component, there is you take advantage of some sort of structure which may be sorting, but in this case it's just for me anyway, maybe in terms of invariant, right? And what I mean by that is invariant is something that you're trying to do to make sure that that all the things you're doing when after you're making another set of change, the same thing doesn't change, right? Like some sort of condition, some sort of state, some sort of things. It's I know it's a little bit vague because it is a general concept versus like a specific thing, right? And in this particular problem, I think the invariant is that you could almost think of it as a subproblem of whatchamacallit. Let me bring up the drawing board actually. And I mean subproblem, maybe like a subsimilar problem, because I think when I talk about subproblem, there is a gravity to think about dynamic programming, right? But it's not quite that. I think the first idea that I would have, or one of the ideas anyway, I don't know if it's the first, is that okay, so you have some like here, right? Like it's the rectangle, and then you have some ones, right? Well, you know, and this is, I'm just drawing the last ones or whatever, right? Well, the thing is that, okay, so let's say I'm looking for a possible. Why just give me a different color? Okay, let's say we're looking at the first row, right? Well, maybe this is not necessarily the best example, but we were trying to find a suitable row to swap into it, right? This one is being primary. But let me change this for a second. Let's pretend this is not true, and we have another one here, right? And you know, and so this one can go here. Okay, so what does that mean? Well, that means that we can pick either of these two, right? So that's true. But what is the invariant? What is something that we can carry over when we look at the second row? Well, the thing with looking at over the second row then, right, is that now everything that, or every quantifier that we put in here, meaning for the first row, meaning for this one and this one, they're naturally always going to also be able to fit into this, right? Meaning that, okay, so we pick this one. It doesn't matter which one I mean, it may matter for the min number, but for in theory, it doesn't matter which one we pick. Is that when we pick here, at least in terms of possibility, if we pick this one can go here, right? Which means that your whatever numbers that you don't use, or rows in this case, you can always use them in the future, and that's the invariance I'm talking about, right? Because and maybe what I explained that way is too obvious in the sense, but not like in a good way, right? It's obvious in the sense that a lot of greedy algorithms, and you know, when you're doing it at home, and this is something that I consciously try to fight myself on, right? Is that when you hear a greedy solution, you're like, oh yeah, of course, it's a greedy solution, it's obvious. And then you look at like, oh yeah, you just have to be greedy on X, Y, and Z, and it's obvious. But like for me, it's like whenever I hear people say that, it shows a disregard, or at least a carelessness about greedy solutions in general, because everything is always obvious when it's the answer. But the question is, can you disprove other obvious solutions so that you don't get a wrong one, right? Okay, but for example, another way that you could have maybe thought about with respect to this invariance is that, let's just say in a very simple way, you did it backwards, right? Let's say you look at here, right? If you just go, okay, what quantifies here, right? What can fit into here, right? Well, you can easily make the wrong choice, right? Because if you just chose this row, well, in this one you can't on the first row. But let's just say you picked, I don't know, you picked this one, right? And then now here, maybe you keep this one. Maybe this is a bad example, but my point is that, in the sense that, okay, let's just say there's another one that's like here, right? And my point is that if you picked this one first instead of this one, then now you're stuck in a impossible state, right? And then the other thing is that, of course, you can go, I mean, you know, and that's one way to do greedy. It's not the right way. You could probably just do, you know, minimize this by choosing this one first, right? And then kind of go step along that way in a greedy sliding window way. So there are different ways to greedy it, but I think for these problems, the way to at least approach them is to think about what I said, right? The invariants. And here there's another invariant that you can think about, but you know, these are what I'm talking about when I'm talking about invariants and things that allow you to be, you know, solve it, right? For me, I'm going to do it the first way. Just, I mean, I guess I could do it both ways now that we think about it. But here, maybe the first thing I want to do is just like convert it to a filter, right? So maybe right? So then now for I in range of n, actually I guess they're both n's, right? Farthest is equal to -1, I guess. And then if grid ij is equal to 1, is it a string 1 or number 1? Number 1. Farthest is equal to j, right? You can write this in number ways, it doesn't matter. And then right? And then now we go, okay, well, for I in range of n, and then number of ways you can write this, but yeah, right. I mean, I'm going to do this very lazily, to be honest, to keep it n square, but you probably can optimize this a bit. I mean, it gets dominated by, because n square is the input size, so, you know, even if you optimize other parts, it will have a constant effect at most, right? But in any case, yeah, so then now, the I flow can hold ones in the ith column at worst, right? So then we just kind of go through them, right? So for j in range of n, right? Or maybe something like for j in range of length of rows, so then we can maybe just manipulate rows, right? Also write total as just a count, right? Oops. So then if row sub j is less than or equal to I, then this is good, right? And then now count it's j because that's the first row, and then we break, but not before we well, we remove it, right? So j plus something like this, and this is the O of n thing that I was saying, right? But yeah, and then else we return -1 or something, and then just return count, and then that's it, right? Straightforward-ish, but definitely, you know, and you know, the code is pretty okay, but like I said, it gets dominated by the conversation around around the invariants, right? Because once you find out the invariant, then all these other things kind of fall into place. That's it. That's all I have for this one. Let me know what you think. I mean, this is n square, right? This is n. It's not highlighted. This is n square. This is n square up to here. I mean, this only happens once per I, so this combination is gonna be n O of n. So this is n square. So everything's just n square. Everything is happy, and n square, of course, is linear, right? Because that's the size of the input. So, you know, it's hard to do better than linear overall. I mean, and of course you can optimize certain things, but I'm not going to. That's it. That's all I have for this one. Let me know what you think. What are the hints? Okay, that's what I did. I'm curious whether there's yeah, I mean, I guess that's exactly what I did. And this is how, oh, the way, I guess I didn't talk about the swaps. I mean, I kind of skipped over it a little bit. So I could talk about the swaps a little bit. Basically, the idea here is that the reason why I did this way instead of another way is because then now, the idea is that we're always swapping the first found row into the first subproblem's row, right? So that means that if this is the this is why this is the number of swaps as a result, because we basically doing one first row at a time, and then first row, and then just go, and then because we delete elements here, it's always just the closest to the top, and that's it. Yeah, that's it. That's all I have for this one. Let me know what you think. Maybe I should read the hints more often after solving so I can make sure that I explain it a little bit better. Because sometimes I make jumps and it's not even like I'm intentional. People are like, can you explain this better? I'm like, listen, if I knew, I could read your mind about what I forgot or didn't, I would just have said it. It's not like, you know, it's not like I leave them out intentionally, but sometimes I just, you know, these are live, so you know it is what it is, and not proofread because you know we do this every day. We have thousands of videos. Anyway, that's it. That's all I have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.